Second method. Today's topic is second method. This is also another method of solving algebraic and transcendental equation. So the procedure of that topic of that method is, suppose this is two-dimensional coordinate system. This is our graph. We need to find its root. So here from the graph we can check this is the root. We need to find out by applying some iterative method a fine approximation of that root. So what we do, we take two initial interval, one initial interval, this one suppose. Obviously by applying Bolzano's intermediate value theorem, that is the end points are of opposite sign, then we will choose this is our required interval. So let this is x0 and this is x1, these 2 points. Then we join the chord between the points x0 and x1. This is why it is called second method. Like this. Okay, then we will get this point, but this is not our root, approximation of our root. So now suppose this the point is x2, then join this point with the chord, with the curve, then you will get another point, name it as x3, then join this x0 point and x3 point like this. Okay, then this chord is cutting the point here. This is our second approximation of the new second approximation of our root. Now check from the first approximation, second approximation is quite nearer with our root. Then we will apply the same thing, join this point also, name this as x4, then join x0 and x4 again. This we will get this point. This is called the third approximation of this root, and so on. So by applying this iterative method, we will get a fine approximation of our required root. Okay, this is the procedure. This is actually the geometrical interpretation of second method. And now we need to get some iterative formula. For that reason, we will do it from this step, naming it A, B, and name the point C. Now from there, from the chord AB, we can write that the slope of AB equals the slope of AC, right? Because they are the same straight line, AB and AC. Now find out their slope. The slope of AB will be fx1 minus fx0 by x1 minus x0 equals the slope of AC 0 minus fx0 by x2 minus x0. All the y coordinates of that point is fx1, this point is fx0, and for this point C, this is lies on the x-axis, so the y coordinate is 0. Okay, so from there what we can conclude, trying to get the value of x2, so x2 minus x0 will be equal to by fx1 minus fx0. Okay. So x2 is x0 plus this whole quantity. So after adding these two, we will get minus plus right, this and this will be cancelled out, so x2 will be equal to x0 fx1 minus fx0 x1 by fx1 minus fx0. This is our first approximation, x2. Now from there, by applying iterative method, we can claim about xn plus 1. What will be it? Just by checking the value of x2, we can say about xn plus 1, it will be here, when here it is 2, it is 0, that means here it is n plus 1, it will be n minus 1, then f of x0 and x1, that means xn minus f of xn minus 1 xn divided by f of xn minus f of xn minus 1. Just a minute. So fxn minus f of xn minus 1. Okay, this is the required rule or required iterative formula for second method. Now we have to use this to solve the algebraic or transcendental equations. So starting with example, a real root of the equation x cube minus 5x plus 1 equals 0 lies in open 0 1. Apply 4 steps of second method. Apply 4 steps of second method to get the root. Apply 4 steps of second method to get the root. Okay, this is our fx. So starting with solving it like this, fx, answer, fx equals x cube minus 5x plus 1. Now it is given that between 0 and 1, one root lies. Let's check it once. f0 is 1 and f of 1 is minus 3. So obviously this is greater than 0, this is less than 0. That means between this interval 0, 1, there obviously exists one root of the equation. So we will take this one as x0, the left hand point, and the right hand point as x1. So x0 is 0, x1 is 1. And f of x0, that is f of 0, which is 1, and f of x1, which is f of 1, which is minus 3. And the formula we know, xn plus 1 equals xn minus 1 f of xn minus xn f of xn minus 1 divided by fxn minus fxn minus 1. Okay, this is our required formula. Now put the values of n 1 by 1 and do it up to 4th step to get the approximated value of our root. Now if you put n equal to 0, you will get x1. We already have it, so no need to put n equals 0. Put n starting from n equal to 1. So when n equal to 1, we will get x2. What will be its value? Just put n equal to 1 over there. x0 fx1 minus fx0 x1 by fx1 minus fx0. This. Now put all the values. x0 is 0, then no need to put fx1, it will be 0 ultimately. So minus, then fx0 1 into x1, which is again 1, so 0 minus 1, then minus 3 minus 1, that is 1 by 4, which is equal 0.25. Right? So find out fx2. This is our x2. So find out fx2. It will be 0.25, its whole cube, minus, just put the value in the equation, minus 5 into 0.25 plus 1. So it will become minus 0.234375. This. Okay. Now moving to n equal to 2. When n equal to 2, we get the value of x3. Put the formula n equal to 2 in the formula. So we will get, it will be x1 f of x2 minus x2 f of x1 by fx2 minus fx1. Okay, this is our new x3. Now put the values over there. So we will get minus 1 into 0.234375 plus 3 into 0.25 minus plus divided by minus 0.234375 plus 3. Now calculate it. The value is plus 0.18644. Right? This one. So find out f of x3. It will be, this is x3, so it will be 0.18644, its whole cube, minus 5 into 0.18644 plus 1 equals 0.07428. Okay, next n equals 3, then x4 equals x2 fx3 minus x3 fx2 by fx3 minus fx2 equal, putting the value 0.25 into 0.07428 plus 0.18644 into 0.234375 whole divided by 0.07428 plus 0.234375. That is, ultimately it will get 0.20174. This is our x4. So get f of x4. This one is 0.00048. Okay. This. So applying, we have applied 4 steps of second method to get the root, and the required root is this one. Though this is actually not a root, this is approximation of a root, because if it was a root, if we put it, f of x4 would be 0, but this is not 0, this is nearer to 0. So ultimately this is an approximation of our root by using second method. Okay, next problem. Find a root of equation x minus e to the power minus x equals 0, x minus e to the power x minus x equals 0, correct to 3 decimal places, 3 decimal places using second method. Okay, this is our equation. We have to find out a root correct to 3 decimal places. So starting with this one, here the interval is not given, right? We need to find out the interval. So the answer is, let fx equals x minus e to the power minus x. Putting x equals 0, f0 equals minus 1, then f of 1 is 0.6321. So this is less than 0, this is greater than 0. Okay, you can take this interval also 0, 1. This is our initial interval. Now we are trying to get if there is some shorter interval. That means, suppose if we draw the graph, this one, right? This is 0, this is 1. Somewhere in between this the root lies. Now we are trying to get some few middle values also, such that suppose we will get this value, and here the root lies. This is positive, this is negative, that is different in sign. That means we will get a smaller interval. The accuracy of our approximation will be more perfect than taking 0, 1 over this. So for that reason we are choosing the points 0.1, 0.2, 0.5, 0.6 and so on, so that we can get a smaller interval. Okay, so that the accuracy is perfect. For that reason we are doing it. Or otherwise, if you can't find the middle points, then you can take 0, 1 also. This is also absolutely correct. Okay, so I'm trying to get some smaller interval. For that, let us choose f of 0.5. Let's take its value. This is 0 minus 0.10653, which is less than 0, and f of 0.6 is 0.0512, which is greater than 0. Okay, I have already calculated 0.1, 2, 0.4 and so on. Now we get this one, 0.5 and 0.6. This is our required interval. We are choosing this is as the initial interval. Okay, You can take the previous interval 0 1 also. In that case you might need to do few more steps to get the root correct to 3 decimal places, because but here we have chosen a smaller interval, so the accuracy will be better and we need to do few less steps to get the 3 decimal places correct. Okay, so this is our required interval. That means this is x0, this is x1, and f of x0 is minus 0.10653, x1 is 0.6, this one. Okay, now putting n equals 1, x2, its value is from the iterative formula. Now put the values: 0.5 into 0.0512 minus minus plus 0.6 into 0.10653 divided by 0.0512 plus 0.10653. We'll get by this one plus this one. So this one. Okay, we have chosen 4 decimal places because we need to take the correct to 3 decimal places. For that reason we choose up to 4 decimal place, so that we can make it correct up to 3 decimal places. This is our x2. Now compute f of x2. It will be this one, okay. This is our first approximation. Now moving to x3. Put the values. Formula will be x1 f of x2 minus x2 f of x1 by fx2 minus fx1, right? Putting all the values. x1 is 0.6 into fx2, fx2 is 0.0006 minus x2. Again the value of x2 is 0.5675 into fx1. What is the value of fx1? It is 0.0512 divided by fx2, that is 0.0006 minus fx1. fx1 is 0.0512. Now calculate it and get the value of x3. Its value will be, writing it in the next line, x3 will be 0.5671, this one. Okay, and we get our x2 was 0.5675. so check 3 decimal places are same here, right? So from that point we can conclude it, but we need to do one more step just to check it. Okay, so for that reason we are computing x4. You can stop it here also because 3 decimal places are correct. So x4 is the formula will be x2 fx3 minus x3 fx2 by this one. For that reason we need fx3 also. We haven't calculated it. So let's first calculate fx3. fx3 will be minus 0.00004. Okay, approaching nearer to 0, right? This one. Now put all these values. Do it yourself, okay? And the value of x4 will be 0.5671. So the x3 was last this, that one, and this is also our x4. So both are equal. We can obviously terminate the step here, and up to 3 decimal places correct. What will be the root? the required root is, if we want to make it 3 decimal place correct, this is 1, that means this will be 0.567. This is our required root, correct up to 3 decimal places. Okay, this is how we solve by using second method. Now I am giving one more example as homework. Write down, find the root of the equation. Find the root of the equation cos x minus x e to the power x equals 0. Cos x minus x e to the power x equals 0 using second method. Using second method with initial estimate. With initial estimate x1 equals 0.5 and x2 equals 1. That is actually x0 and x1. x0 is 0.5 and x1 equals 1. That is, this is our initial interval. Using this, you need to apply second method. Now here nothing is mentioned, that is up to which steps you have to do that, or up to which decimal places or significant figure you need to find the root. So here you can do it by yours, apply 2-3 steps and get an required approximation. Okay.